The goal of today's lesson is twofold. The first is if we have an expression, not an equation, but an expression, what values for that expression uh, would result are in the denominator being equal to 0, which then means the expression is undefined, so that it's what we call an excluded value. Then the second part, or the second goal, is when we solve an equation. So now we're looking for what's the value of, or values of x or y, whatever the variable is. What values do we get when we solve the equation, and check to make sure that those solutions are acceptable. So let's take a look at three pretty straightforward examples. I'm going to solve each of these three by cross multiplying. All right, you remember all of these are proportions. There's a fictitious 1 under the 2. So you simply get x is equal to 6. And how you check that, you substitute back into the original, and you see that it works. I'm going to do the same thing here. I cross multiplied. I add 4. Remember, this is a linear equation. So I'm not setting it equal to 0 to solve. I'm getting the variables to one side and the numbers to the other. I get x equals 4. I check it. And that works also. Now I come to the third one. And again, I'm going to cross multiply. Now you notice that this is a quadratic equation because the x has an exponent of 2. I'm going to subtract 2x and add 4 to both sides because I want to set it equal to 0. To be able to solve this, I need to factor. It's a trinomial. I'm going to use I am. And it happens to be what's called a perfect square trinomial, meaning both its factors are the same. So I get an answer of 2 for x. However, when I go back and substitute in, you'll notice that I get 0 in my denominator. And that's a problem because that is an undefined value. So what conclusion can be drawn from the three problems above? In problem 3, the solution results in 0 in the denominator, which is undefined. What we call that in math is an excluded value or an extraneous solution. So the definition of an excluded value is any value that makes the denominator 0, which makes the fraction undefined. Okay, so we're going to divide up what we're going to do here into two parts. The first 4 problems are going to be as follows. All we want to do is identify the excluded values. Hopefully you'll recognize that since none of these are an equation, I can't figure out what the value of x is. All I am looking for is for you to tell me what x cannot be. How do you do that? You set the denominator equal to 0, solve, and so you tell me that x cannot be -5. It can be any other real number that exists, but it cannot be -5. I don't care about the numerator throughout this exercise. I set my denominator equal to 0. You will factor using dots. I get s is -3, x is positive 3. So x cannot equal 3 and negative 3. For my next example, set it equal to 0. I factor using I am, what adds to negative 2, and multiplies to negative 24. I get my two answers, and then I have you tell me that x cannot equal 6 and negative 4. Now I ask you to create a fraction that has excluded values of 3 and negative 5. Well, it's kind of going backwards. If the answer was 3, as you'll see in the example above here, then that means right before that, the parenthesis had to be x minus 3. And if my answer is negative 5, then the parenthesis right before it had to be x plus 5. I don't care what's in the numerator, so I'm just actually going to ignore it. I then will multiply this out to get the following trinomial as my answer. Okay? So all we did in these four problems is identify the excluded values. Okay? We did not solve for x. Now I'm going to solve for x. What are we going to do? We're going to do just like you did in the do now. You're going to cross multiply. You get 3x equals x minus 2. This is a linear equation. Get the x's to one side, or the variables to one side, and get the numbers to the other. I get x is equal to negative 1. If I were to substitute negative 1 in for x, you'll see that I do not get 0 in the denominator, so this is all good. Now I go to the next one. What you have to make sure you are doing here is using properly the distributive property. This is 4 times x minus 1. That's 4x minus 4. This is x plus 3 times x minus 1. You have to multiply out 4 times, and that's how you get x squared plus 2x minus 3. Hopefully, you recognize that this is a quadratic equation because of the x squared. Therefore, you want to set it equal to 0. The x squared is already positive, so I want it to stay on that side. Now I have a trinomial. You should be looking to do I am because there is no greatest common factor. And you're going to see x minus 1, x minus 1. So my solution is x is equal to 1. However, when I go and substitute in, you should clearly see, and all it has to do is fail in one of the fractions, that I end up with 0 in my denominator, so I have no solution. That means there is no real number that will satisfy this equation. It's unsolvable in the real number system. Now I'm going to go to example 11. Again, we cross multiply. Since the larger x squared, it's 2x squared, is on the left side, I want to move everything over to the left by subtracting x squared and 6x. Please remember how to do the combining of your like terms. There's a video on that if you don't remember. 2x squared minus x squared is x squared. You don't change the variable when adding or subtracting. You just add or subtract the coefficient. Minus 6x minus 72. Please write your trinomial in proper order, starting with the highest exponent with the variable on down. If you were to mix this up, then you're trying to do I am is not going to work at all, and you're going to just confuse yourself. So now I want to factor this. You get minus 12 and a plus 6. You set each one equal to 0. You get two solutions. However, when you substitute them in, The 12 is okay, but the negative 6 is not in this fraction. It doesn't work because it makes that a 0. So this is not a solution. My only solution is 12. Okay? And you need to do something to communicate that to me. Now, the last example, you cross multiply, and you get an identity statement. So your natural reaction is to say, oh, all real numbers is the solution. The answer is not necessarily. X is a real number, except X cannot equal -3, because that value makes your denominator 0. If I were to do that on a number line, which we've seen before, open circle on -3, and arrows going in both directions. So the point to today's lesson was twofold. One, to identify what are called excluded values, meaning what values are there that give me a 0 in the denominator. All I did was identify what they were. Those were when I had variable expressions. Then secondly, if I were solving an equation, I would solve the equation just like we've been doing, and then I have to check that any answer that I got does not lead to 0 in the denominator, because if it does, then it's an excluded value, meaning it's not a solution, and we call it excluded value or an extraneous solution.